My name is Tamar. You can follow me on those links and contact me on those links. And I'm really passionate about JavaScript and Node.js. And my interest in those technologies started when I founded a startup of my own and I wrote the entire backend in Node.js. And from there, the rest is history. And okay, enough talking about myself. Let's start talking about performance, which is one of my favorite things that I like to talk about. And today we are going to talk about how we're gonna improve performance in your API layer. And we're gonna, revise, we're gonna look at those, areas, we're gonna look at database, we're gonna look about like the serialization and deserialization of your JSONs. We're gonna talk about like logging. It looks trivial to you, but yeah, I mean, that can impact your performance, the web framework that you choose, and caching. All right, so let's start with database work. So first of all, before we go into like JavaScript related stuff, there are some things that you need to keep in mind for every technology that you work with, for every programming language. First of all, of course, your DB queries has to be optimized. All of the indexes has to be very efficient and enable really fast fetching and efficient operations. Then you need to denormalize your data. What does it mean? That if you have a table of 50 columns and you only need 3, don't fetch the entire 50. Fetch only what you need, for example, and save the data in a way which is efficient. Don't save inefficient things. And then you need to think about solutions in the DB layer that can be like read-write replicas that can improve your performance, working with a replica set with the matching DBs that support that, and sharding. But we are in a Node.js conference, and after talking a little bit about like generic tips, let's go into Node.js stuff. So how can I improve my Node.js application related database work? So all of us, when we're starting to work with Node.js, we're starting to work with the first tutorial that we're all doing, Node.js, Express, and Mongoose. So let's start with that and let's take a benchmark and see how that is going to perform. When we're going to do a benchmark, we have to keep in mind the following things. First of all, the measurements that are the most important is, first of all, the latency. You need to look at the 99th percentile, not the average, because when you're looking at when you're telling, you have a contract with a third party and you're telling them, all of my requests are faster than this, you need to give them the 99th percentile in the latency, not the median, not the average. That's really important. Second, measuring throughput. And for measuring throughput, we have 2 important things that we need to look at. First is the average request per second, and then the total request. Those measurements will give you a good idea about how your throughput is improving. Okay, so now we're gonna compare Mongoose and native Mongo driver. So I wrote a server which works with Mongoose, and that server exposed one post request that is posting a person object, something really simple. The code is, not something really interesting. We're building a server with Express and Mongoose, building a Mongoose schema of several parameters, and then that's like the function that we're going to measure. Post, and then we're creating a new person object and saving it, as you can see here. The native Mongo driver code is going to do exactly the same. A post request, which also is posting a person object, and that is because we want to compare apples to apples. When we're doing performance benchmark, we want to compare things that are doing the same. So here is like the code that is running with the native Mongo driver. And as you can see, this also is just like doing insert one into the database. Okay, cool. So those are the results that we have with Mongoose. You can see if we're going to look at average requests per second, we are in around 5,700 requests. And the total request is around 64,000. And the 99th percentiles is 4 milliseconds. But as we're using Mongo driver, we can see that things like improved hugely. We can see that the average request per second went up to 9,500, which is a lot. It's more than 30%, I think. The 99th percentile is much smaller, by 50%. And we were able to serve in the time of the benchmark around 30,000% more requests. And as you can see, if we're going to see it in the graphs, so yeah, native Mongo driver performs much better than Mongoose. And we're going to compare total requests and average requests per second, and you're going to see that it's much better. So the question is asked, why it is much better? Why it is performing much, much better? So to make a long story short, Mongoose is a tool from a type called ORMs. And usually when you're using those tools, there are much more out there. They give you an abstraction layer above your database that helps you, but it adds like an overhead of serialization, deserialization, sometimes inefficient queries. So usually most ORMs harm your performance. Those are good for like applications in low scale, medium scale, but when you're going to high scale, usually you're starting to work like natively with your database, whether it's Mongo or SQL or whatever. Then let's talk a little bit about connection pools. So what are connection pools? When we're working with a database, then we want to have a pool of connections to the database that will be available. Each one of them can execute a query, and when it ends, it goes back to the pool, waiting for another client, another utility to use it. All right, so if we're going to compare results when we're working with a connection pool to your database and working without a connection pool. So now let's do that comparison. Again, we're comparing apples to apples, and we're comparing the same server, and that server is doing that post request that we've spoke about. So when we have no connection pool, that let's look at the throughput. We see that the average request per second is around 8,100, and the total request is about 81,000. Wow, we have like a multiply of 10 here. And then you can see that if we're optimizing our connection pool, making it bigger and making it more efficient to our like machine needs, to our environment, then I succeeded to get like around 15 to 20% improvement. We can see that the average request went up to 9,500. The total amount of requests is a little bit close to 100,000 requests. And if we're going to look at that with graphs, then we can see that when we were optimizing our connection pool, then the performance went up by 20%. So we're looking at the total requests, the average requests, also the latency became shorter. So another thing which is important to keep in mind then to work with a connection pool and make sure that you're optimizing it. All right, now let's talk about efficient JSON parsing and stringify. So when we're working with an HTTP, when we are using a post request, when we're implementing a post request, we are deserializing the HTTP request, the body of the request. And when we are implementing a GET request, we are serializing the response body and giving it back to the server. But serialization and deserialization is a synchronous operation that always blocks your event loop. I really hope that you have like Node.js architecture in mind, that you're familiar with the event loop that is, processing, activities, processing work. And when we have a synchronous operation, which is long, it's blocking it. And serialization and deserialization are exactly those things. So now I'm going to take the same server and replace the response serialization with another library called fast-json stringify. And let's see what we're going to get here. So if we're going to work, I'm implementing a get API here, and I'm working with Express, and I'm using Express.json, as you can see, like the default serializer, and that is a function that I'm testing. And well, Express.json is like executed on when we're doing result.json. Okay, so we're doing find one and returning the response. Now I added a little bit of addition of my own. I created another server. I used fast-json stringify. That library needs to receive a schema, so I gave it a schema, as you can see here. And I created a middleware of myself, and I replaced the default Express serializer with my middleware. And that middleware is using fast-json stringify, that custom middleware. And if we're going to compare those results, we're going to see that that gave me also around 15% improvement to my Express server. For example, the average request went up to above 10,000 requests per second. And also the total requests, those went up in around like 50%. I was able to serve more, like 50% request more. So the throughput went up, and also the latency is smaller. So fast-json stringify gave me the performance advantage here. But that's not the only library that exists around. There are more libraries that exist, and I really recommend you to look for other serializers, understand what is more efficient, and doing your test. And maybe, yes, consider making this layer of serializing and deserializing your requests and response content more efficient. All right, let's talk a little bit about logging. So in a perfect world, our system is working perfectly, but actually, usually in reality, there are a lot of problems. Application is crashes, there are random bugs, data is missing. So logging always helps us to debug, and logging is something that we all need in our applications. But logging can cause performance degradation. So it cannot, it will always cause performance degradation. So I was comparing one server with a post request that is, with no logs, and another server which have only one log line, and that's it. And look what we have here. If with no log, the average request per second is around 9,600, then when we have only one log line, the throughput is down by around 15%. Look at here, the average request per second is around 8,400. In the last results, we were able to serve like around 100,000 requests in the total benchmark. Now we're able to serve like 93,000. That is like 10% degradation. So when you're thinking about logging, that's also something that you need to take in mind, to take a library which is performance efficient. Different log libraries that are, popular right now are, let's say, Windstone, Pino.js, and other libraries that I took for my benchmark comparisons are Banyan and Log4j. So when we're looking at the overall, we're going to see that Pinot.js is the library that currently gives you the less overhead over your code, meaning that that is, like, for now, for my comparisons, the most efficient log library performance wise, and it would give you like the best results for not harming your application performance. So we can see that in the average request per second, and we can also see it in the total request, as you see that like the Pinot, the server with Pinot was able to serve like the amount of requests which is closer to a server with 0 logs. So if we're conclusioning that, so if you're thinking about performance and you're thinking about performance efficiency, so prefer Pinot.js over other libraries. That can change, but that is, like, for now, the most efficient log library out there. Another tip that I would like to give you, which is important, is, when we're doing logs, we have a lot of string concatenations. But the log library should manage the string concatenation. Don't do the string concatenation in your application by yourself, as you can see in the example which is below, because it seems like minor to you. What is actually happening behind the scene, that if my log level for now is like error, then that string concatenation won't be done by the log library. And if I'm doing it by myself, it will always happen. So it looks minor, but really in like large application, complex application, those things adds up. So always prefer that the string building would happen with like an interface, would happen with an interface which is suitable for that from the log library, which receives parameters. Okay, now actually I was doing like tons of examples with Express. So the question is whether we can do something else, maybe not Express. I mean, Express is, to be honest, is kind of old. I don't know if you know that, but Express release version is version 4, and that was released in 2014. That was quite a long time ago. And I know that, like the first tutorial is Express, but we have like a lot of other players, interesting players in the market. We have Nest, we have Fastify, we have Koa. So maybe if we're going to take something else that can give us like an advantage that we need. So I was benchmarking Express and Fastify and Nest.js. And of course, when benchmarking, it's very important to, as we said, compare apples to apples. If I'm comparing a GET request that saved an object, a person object with 3 parameters, I have to do the same thing with the Fastify and with Nest, like the code has to be the same. And on the database, if we're doing insert 1, we need to do insert 1 on the other framework. Okay, let's see what we get. So when we're working with Express, we were able to serve around 400 requests per second, and the throughput is around 100,000 requests per second, and latency 2 milliseconds. Nest gave us something which is slower. Average request per second 5,400. We were able to serve around 60,000 requests, but Fastify currently gave us the best results. We were able to serve, as you can see, close to 200,000 requests per second. The latency went down to 1 millisecond. So Fastify gave us the performance edge. And here is like the comparison. Like if we're gonna look at it like visually, then we're gonna see that Nest was performing about 50% slower than Express, but Fastify is currently around twice faster than Express at least from my benchmarking. And we can see that with multiple measurements that was done. So actually, in most companies, it is a little bit hard, let's say it, to refactor your microservices code. Usually you get a code that you need to work on. And on that case, well, you have what to do. You can make your DB work more efficient. You can use the caching. We're going to talk about caching right away. You can improve serialization, but if you have a possibility to choose a more efficient web framework, or if you have a possibility to like start a new microservice with a different web framework in your organization, you should really consider that, because that can give you a really boost and edge. And as we said, Fastify currently is the framework which is performing the best among all the framework that I looked at. Now, I hope that your mind is not blown, but we're going into the last thing that we're going to talk about, which is caching. So for that, I had implemented a server which is authenticated with JWT. And token validation is done in JWT authentication in both sides. The client has to validate the token, and the server has to validate the token as well. But I'll give you a spoiler. Adding a JWT authentication to the server has caused the server to, like, the performance to, like, decrease in a really bad way. Let's see that. So that is the middleware that I added, and for every request I'm doing JWT verify for the token. Okay, the code is not really complicated here. So that is the middleware that is used, and look what happened. So from a situation where we're serving around 100,000 requests in total, we went to around 15,000. That is like 80% degradation. That is huge. So yeah, like things, and also the latency, went up to around 10 milliseconds. It was like massive. So to solve the problem, well, the best thing to do here to solve the problem is to use caching, actually. So those are the results when we have no authentication. That's what we got. We know that around 9,500, 9,600. Those are the results that we received when we added the authentication. You see that the average request per second went down to 2,500. And when we're using caching, you can see that we're really close to what we had in the beginning. We had, like, without the authentication, we had around 9,500 requests per second. Here we have 9,100. That is kind of close. And also, we can see that the latency is back to 2 milliseconds, the 99th percentile. That's what we're looking at all the time. And here you can see it like visually. When we were adding caching, it is close to what we have. When we're doing no authentication at all. So adding caching to the authentication layer solved the problem. All right, so we can see it with different measurements, and we can see that the latency is back to what it was. So that was the bottleneck, and the performance problem was solved. So types of caching that we can do in memory, but actually that is not really recommended, because most of the time, if you're doing in-memory caching, you cannot run your service in multiple replicas. You cannot like create multiple instances of your service, so it's not recommended. Better to take technologies like Redis. Redis has other like competitors like etcd, for example, but better take technologies like this. And in that case, the cache is distributed. All your services are accessing the cache. and it's much better. Okay, what you should cache, or what is like recommended to cache: DB queries, crypto stuff. For example, we saw JWT, HTTP requests from third party, those kind of things that would like improve your performance a lot. Okay, we are at the end of this, which is good. So let's do like a quick summary of everything that we've seen. Optimize DB queries. Make sure you have like efficient DB architecture, as we've talked about. Better to work with native DB drivers in large scales. Have your ability to optimize your connection pool. Cache stuff when you need. And also make sure that you choose an efficient web framework for performance. You choose efficient log libraries, and you choose efficient serializer. That was me. I really hope you enjoyed it, and you can follow me on those links. And thank you very